Welcome back. We'll carry on with a few extra problems here, see kind of how far we get. I do want you to know that when you look at my copy, it may look a little bit different than the one that you're utilizing because I chose to space it down a little bit to give myself a little bit more room so I could write a few extra notes here and there as necessary as I went through this process. Let me turn off the screen behind me real quick. Probably shouldn't have that on when I don't need it. So anyway, let's see what we can do. So we're going to look at problems, probably maybe 5, 6, and 7. We'll see how long that takes, but here we go. So this is a problem that was brought back because of people's really frustration with it in the last test. So I felt like since we were really not particularly successful, let's take another look. So first off, if it is to be differentiable, the first thing that it also must be is continuous, because differentiability implies continuity. It has to be continuous to be differentiable. So if we look at the limit as x approaches 2 from the left side, as you get close to 2, we're going to get very close to 8a plus 4 minus 4. Again, I'm not writing this in a super formal way because this is like a multiple choice question, but remember I could say something like, I could say the limit as x goes to 2 from the left side would be this value. But then as I go to 2 from the right side, that has to be exactly the same value. 2 minus 3 is, of course, -1, which squared is 1. So plus 4. So what I have is that 8a is equal to b plus 4. And hopefully that, wait, nope, it was 4x, excuse me. So that would be equal to b plus 8. Let me fix that real quick. So 8a is the same as b plus 8. So this would ensure continuity. So if those two things are the same, we would definitely have a continuous function, but it doesn't guarantee that it would also be smooth and therefore differentiable. So the next thing I'm going to do is I'm going to find out what f prime of x is. And again, I need that f prime to also work. So let's see. If I took the derivative, I would get 3ax squared plus 2x, and the 4, of course, would disappear. I come into this one, I would have 2 times b, let's see, and that's x minus 3 to the first power, and the derivative of 4x is 4. So again, if I were to play the same game that I played on this problem and say, hey, I would like to make sure that as I approach 2 from the left side, now as I approach 2 from the left side, this would be getting close to, why did I write it that way? It'd be 3ax squared. Let's fix that. And then 2x. So as I get really close to, I don't really like how I wrote that. Let me fix that. Sometimes I just get moving too fast. So 3ax squared plus 2x, that feels better. So as I get close to 2 from the left side, this is going to get close to 4. So it's going to get very close to 12a plus 4. And then as we go to the other side, as x gets very, very close to the number 2, this is going to be a -1. And so we get 2b times -1 and then plus 4. And immediately what I noticed, which was quite convenient, is these 4's right here cancel. And so I end up with this nice little fact that 12 times a is -2 times b, or in other words, b is -6a. Now, again, what I have is 2 equations with 2 unknowns. So if I came back here and I plugged that in, I know that 8a is the same as b, but we just found out that b is -6a. So 14a is 8. A is 8/14, also known as 4/7. Now, this problem didn't ask me to go any further on that. It just said, what is A? But I want to find B really quick. So, of course, according to this, if I know what A is, take this times 4/7, I would get -24/7. Now, on a test, you would not have the ability to do that, but as we're learning curriculum, we want to make sure that we're testing ourselves and make sure we're doing well. So I did put together a quick little Desmos, and let's see what we have. So I typed in the equation, and please notice that we decided to make A specifically the number 4/7. So that's going to change that thing a little bit. And I decided in order to make that true, I needed b to be negative 24/7. And what you'll notice is right there, the two are stitched together absolutely perfect. And there is no way by looking at it, if somebody showed you that graph, other than the fact that we have differing colors, but if I change the colors, all of a sudden there would be no way to know that I actually did stitch two graphs together. And that definitely makes it both continuous as well as differentiable. It is smooth at that place. So let's go back to this. So we've got that down. Now, number 6, we're saying, hey, I would like this particle to be moving to the right, which in other words means if I have my position function, I would want to have a positive velocity, which would imply that it moves to the right. So what I'm going to do first is I'm going to find v of t, which would be negative 36t squared plus 30t minus 4. And I'm not really a big fan of the way that looks because I don't like leading coefficients that are that gross. So I decided I factored a -2 out of everybody. That felt a little bit nicer. And I've got to say, I looked at that and I was like, oh my gosh, is that even factorable? Because to be honest, I looked at it and I like, that doesn't jump out at me. So I will say that I went out here and I did a quick diamond, mainly not to do the math, just to find out, did I need to go to the quadratic formula? But then I thought, you know what, that was kind of silly. I'm just kind of going through my own thought process because the first time I did this problem, that's what I did. Is I said, well, let's think about this. But notice there's some hints up here. And it's either going to be 5/12, but see, the thing is or 12/5, but 12/5 isn't even a possible root of these. But I could see 1/6 is a possible root and 2/3 are possible roots. So I kind of cheated and said, hey, well, the answers gave me some information about it. And so I said, well, if 1/6 is a root, and that would be something like 6t. Double check when I'm writing down 6t minus 1 times, let's see, to get 18, it'd be 3t minus 2. And if we just try to distribute that out, that does give me 18t squared and -12 and -3. This does work. And so keep in mind what we are looking at is we are looking at a quadratic with roots of 1/6 and 2/3. It is a down-sloping parabola, which means it should have this kind of shape, meaning it's up in the middle but down on the two sides. But that's what the parabola would look like. But the interpretation, if this is the velocity, is it's going backwards or left, forwards or right, and then backwards or left. So the only place that is strictly moving to the right would be the value between 1/6 and 2/3. Okay, cool, got it. All right. Next one, number 7. This now, right at first glance, looks at it like, oh my gosh, what a crazy hard problem. Oh no, I have to do the formal definition of a derivative. No, it says find the limit. And if you recognize that this is a limit, remember, it is the limit f prime of x is the limit as h goes to 0 of f of x plus h minus f of x all over h. So the derivative is the derivative of that function right there. And if we look at this problem, I am being asked to take the derivative of a tangent of 3x. And I know that the derivative of a tangent, remember chain rule, we're going to take the derivative of the first part first. So the secant squared of 3x. And then we're going to go into the inside and take a derivative of the inside piece, which of course is 3. So it would be 3 times the secant squared of 3x. That is answer B. Cool. And I actually didn't have to do the limit. That would have been very, very difficult and would have taken quite a bit of time, but we didn't need that. So here's the last one for this particular video, problem number 8. So we've got this chart. And in fact, I actually took this problem. This was a test question. I believe it was last year. It's not a test question this year. I chose to change that. But I want to find h prime of 3. So here's h, and I've got all this data up here. So I know that h prime of x would be, chain rule says take the derivative of the outside function times the derivative of the inside function. And of course, the derivative of 8 is 0. So if I wanted to find h prime of 3, I need to take f prime. Now I'm going to plug in 3 everywhere where I have an x, which is just that same strategy we've been doing for years. And so I need to go up here and find g of 3, and g of 3 is 2. So I'm going to replace g of 3 with 2, and I'm going to replace g prime of 3 with -3. And then all I have left to do is find f prime of 2, which is -2. And I got that result was 6. Drop something. Sorry about that. Now, similar problem. Now we got a composite and we're moving things around. So this the h prime of 2 would be, let's see, h prime of x would be f prime. We're going to leave the interior portion alone and then multiply by the derivative of the inside piece. And then there's going to be an extra 2 because of the chain rule. I had to work from the f to the g to that. I have 3 steps, 1, 2, and 3. And then we're going to, of course, plug in the number 2. And if we plug in the number 2, 2 times 2 is 4, 4 minus 1 is 3, f prime of g of 3. Well, that was done on purpose. We already did f prime of g of 3 right here. This was f prime of g of 3. That was -2. If we plug in the number 2 right here, we get g prime of 3. Well, we already found g prime of 3 is -3. But this problem is a hair different because that chain rule had that 2 that came along for the ride. And so we ended up with the number 12. All right. Well, I feel like that went relatively quickly. So we might be able to do one more problem. So let's take a look at number 9, and then I will put this one to bed, and we'll see about another one in a minute. So first off, it said, let's find the equation of the tangent to the curve. So the first thing that I know is it's going to go through 7/8, and it's going to go through 3. And that's going to be the same for both of these problems, whether it is a normal to the curve or the tangent to the curve. We definitely are going to have those values. I just need the slope of the tangent line to go right here. So I need to go take a derivative. So this is really partially just keeping our practice in on doing our quotient rule. So I'm going to start off with my low, d high, but d high is going to be 2, minus our high, and our d low is going to be 3 over the square of what's below. Okay, so it's a low d high minus high d low. Low, the d high is 2, the d low is 3. Now, I do need to do a little distributive property because I would like to simplify that a little bit if I could. And that gives me this, 3 times 2x is 6x plus 3. So 3x minus 1 squared. Hey, something cool just happened. The 6x is canceled. 6x minus 6x, and -2 minus 3 is -5. Well, that was pretty nice. So I got -5 over 3x minus 1 squared. And so if I wanted to find the slope of the line at that value, then I know x is 3. So I want to find what is g prime specifically at 3. So if I plugged in 3, 3 times 3 is 9. 9 minus 1 is 8. And 8 squared, of course, is 64. So this would be -5 over 64, which of course means that the normal to the curve would be 64/5. And this was not intended to really be a second question. It was just sort of saying, hey, sometimes we ask this one, sometimes we ask this one, but really the level of work is identical regardless. You just got to remember if you take the slope as it comes, or if you choose to flip it over. And that should be sufficient for those set of problems. And I hope that was helpful, and I will see you back in class. Bye-bye.